Hi, my name is Gutierrez-Ray, and I'll be participating in Challenge 2017. Today I'll be talking to you about derivatives. So, the premise of a derivative is that it is used basically to give us more information about a particle in question. So say we were to have a car that was represented by a certain function. That function of the car would really only tell us that car's path of motion. It would not give us much else information. It would just tell us where it is moving. We know that it is moving, and so because of this, we are able to take its derivative. Now, by taking the derivative of the car function, we're able to determine the speed of the car. So again, now we have two pieces of a puzzle. We'll have where a car is located and how it's moving, and then we have its speed. So we know how it's behaving, and now we know how quickly it's behaving. So derivatives are fairly useful in many ways, and are a critical part of physics and many other different things. Now, as far as solving differential equations, there are four basic rules per se to solving these. These are the most basic and fundamental rules of derivatives that will help you solve differential equations. Now, the first is the derivative of a constant. This can be denoted as d over dx of c, c representing a constant number. An example of this would be f of x is equal to 3. Now, in a situation where you have a function that is equal to a constant, and you're trying to take the derivative of that number, or of that function, it is always equal to 0. And this is true for all functions that are equal to a constant. The second rule is power rule. This is when you are trying to solve a differential equation that has a variable raised to a power. This is denoted by d over dx of x raised to the nth power. So now in situations like this, you follow the general form of setting the power, multiplying x raised to the n minus 1 by n. So an example of this in action is the function f of x is equal to 6x raised to the second power. So this, if we're deriving this, we would multiply the 6 by the power, which was 2, times x raised to the power minus 1. So this results in 12x. Now our third rule is product rule. Product rule is when you're trying to multiply, or when you're trying to derive a function that is basically two functions multiplied by each other. So if we had function f of x times function g of x, you would solve it by multiplying g of x times the derivative of f of x and adding that to f of x times the derivative of g of x. So this can be denoted, though, is d over dx of f of x times g of x, or d over dx of u times v. And these are just kind of placeholders for actual functions. So an example of this is if the function f of x were equal to x squared and y times y squared. X squared being the function f of x and y squared being the function g of x in this situation. So the derivative of that would be the function g of x times the derivative of f of x. So that's going to be y squared, and now we know from power rule that this is going to be 2x plus the function f of x times the derivative of g of x, which is going to be 2y. And then if we simplify this out, we'll have the derivative of x squared times y squared is equal to 2xy squared plus 2yx squared. And this is product rule. And finally, we move along to quotient rule. So we have constants, we have powers, we have product, and now we have quotient rule. Quotient rule is when you're trying to differentiate a function that is in the form of a quotient. How nice. So this quotient rule is seen, you know you need to use quotient rule when you see something like a function on top of another function. So this can be denoted as d over dx of f of x over g of x, or d over dx of u over v. So this is one function on top of another function. And so the general form, which you just kind of plug your numbers into when solving, is g of x times f prime of x minus f of x times g prime of x divided by g of x squared, or whatever function is in the denominator. If this were to be flipped, then these numbers would be flipped as well, and it would be, f of x squared. But in this case, it is not. So an example of this would be if we had the function f of x were equal to 2x over y. So in this case, we'll say that 2x is equal to f of x and y is equal to g of x. So as we're solving, the derivative of that would be g of x times the derivative of f of x. So this would be y times 2 minus, and then we have f of x times the derivative of g of x, so 2x times 1. And this would all be over the denominator squared. And so in this case, it is y squared. And so once we go through and we simplify, we're able to see that the solution to the problem is 2y minus 2x over y squared. So those are the 4 basic rules for derivatives, and they get pretty complicated as you go on. But for right now, those will help you solve most general problems. And even once you get onto something scarier like chain rule, they're basically the building blocks of what differentiation is. So hopefully this is helpful and you learned a little something or got a refresher. And I don't know, let me know if it was actually helpful.